Okay, so today we're going to talk about exponential growth only. So we're going to start with that. So the growth function is going to start off small and then get rapidly and more rapidly as it goes, get higher and higher and higher and higher. Okay, now super important right here, and I copied it for you. The way this looks is technically this way: y equals a times b to the x power. Okay, so here's the different things. So a, whatever it starts with, right, is the initial amount we start with. Okay, so if we're talking about bacteria, it means like how many bacteria started in a wound, let's say. Like if you cut yourself on a rusty nail and you it gets 5 little bacterium in there, that's going to be this value. The b value is the growth factor, like how fast is this guy growing. So if it is growing, it's good, that b value, whatever it is going to be bigger, 1 or larger. All right, if it's decaying, it's going to be less than 1. All right, if it's going down. But we're going to talk about growth. So this means that it's going to be the rate at the growth factor here, and the x is the exponent. Okay, so let me show you in here. So let's start with money, which is super important for all of us at some point. When you guys get old enough and you can start investing or talking about money, this is how this is going to work. Okay, basically. Since 2005, the amount of money spent at restaurants in the United States has increased about 7% each year. In 2005, $360 billion was spent at restaurants. If the trend continues, about how much money was spent, because this is a while, in restaurants in 2015. Okay, so this is how you do this. You set it up exactly as we see up above. So we're going to start with y equals, what is our initial value in this case? What is it? 360 billion. So I'm going to write it at, you can either write it as 360 and then in the end know your answer is in billions, okay? Or you could write it out with all of the zeros. I don't recommend doing that. Okay, 360 billion. Now, what is our growth rate? That's our next thing that we need to do. Times. What's our growth rate? 7%. But I just told you it has to be above 1, right? To be growing. So I know 7% written as a decimal, right? Where do we move the decimal? To the left or the right? To the left. How many spots? 2. Okay. We move that 1, 2 spaces, right? So 7% is actually equal to 0.07 as a decimal. Okay, does everyone remember that? Yeah. Now, that's less than 1, isn't it? So to make it grow, you need to put a 1 in front of that. The 1 then accounts for this initial value, because 360 times 1, that accounts for your 360 billion. And then you put the 0.07 behind that. Okay, so growth has to start with, if it doesn't start with a 1, you put the 1 in front of that. Okay, and then the exponent is x. Now, in this case, now we're going to substitute a number in for x. So we're trying to figure out 2015, the amount of money spent in restaurants. So what number do I have to put in for x? Ezekiel. That's right. Why is it 10? There you go. Started in 2005. We're asking for 2015. So we're going to put in 360 times 1.07 to the 10th power. Okay. Now, there are 2 ways you can put this in your calculator. You can either put it in as seen, right? So you can do 1.07 to the 10th power times 360. You can also go to your y equals, because sometimes they're going to ask you multiple values, right? So if I go to my y equals and I put the function in 360 times 1.07 to the x power like this, right? And then I go to the table. What value am I looking for X? For 10th, right? But this tells me all the years. This tells me at year 0, the starting amount is 360. It tells me how much it was at year 1, 2, 3, right? Which they sometimes ask you about. So sometimes it's better to put it in and get the whole table. So how many billions of dollars were spent in 2015 at restaurants? 700.17 billion, right? So y equals 708.17, but you have to write the word billion behind that because this is in billions of dollars, okay? Or you can move the decimal back, right, so that you're in billions. What is the expression that represents the equivalent monthly increase of spending at U.S. restaurants in 2005? Okay, so if we have to change from yearly, so my yearly equation was this. Oops. That's for per year. How is this equation going to change for months? What's it going to do?
Going to divide the 360 by 12.
Nope. You're on the right track, but we're not going to divide 360 by 12. This is yearly, right? Which part of this represents the number of years? The X, right? So if we change it to monthly, what do we got to do to that X? If this is years, how do I change it to months? David was on the right track. How many years are in a month, or months are in a year? 12. So what do I have to do to the years? Divide it by 12. This is what it will look like. It's okay to have your exponent be a division or a fraction of dividing. All right. So you're on the right track where we're dividing something by 12, but it's not the initial value. It's going to be the months or the time. Okay. So that's writing the equations and kind of finding that. All right. Let's flip over. So there is this thing in the world. It is called compound interest, okay? And compound interest, what that means is that if you put your money into something and it pays you interest on your money, right? Like how many of you have your money in a bank account right now? Okay, so a few of you. Do you know if your bank account pays you interest on your money? So many bank accounts do, all right? Many bank accounts will, if you open a bank account and keep a certain amount in there, every year or every quarter, they will pay you a percentage of money just for keeping your money in the bank account. So you make money just by keeping it in the bank, by doing nothing else, by keeping it in the bank, okay? Now, compound interest is you make interest on your money that's in the account, and then so you make that money, right? And now you have more money in there. Then the next year you make interest on your money plus the interest that they gave you. So now you're making interest on the interest. That's called compound interest, right? And so there's an equation for it. It looks like this. This is something that's super important. Let's see if we can make sure everybody can see this if they're watching the video by highlighting. All right. It's not working super well, so I'm going to rewrite that. A equals P times 1 plus R divided by N. And then the exponent is N times T, like that. This is the compound interest formula. And I copied what it means. A is the balance, or how much is in there. That's what we're figuring out. P is the principal, not like the principal of a school. The principal is the initial deposit of money, what you put in right away. R is the annual interest rate expressed as a decimal, right? Not as a percentage. N is the number of times the interest is compounded per year. So what that means is like compounded means paid out per year. Sometimes it's paid once per year. Sometimes it's paid Like semi-annually means twice per year. What does quarterly mean? 4 per year, right? Sometimes it's paid monthly. And then T is the time in years, okay? And so let me show you how this works. So suppose that when your friend was born, your friend's parents deposited $2,000 into an account paying 4.5% interest compounded quarterly. What will the account balance be after 18 years? So some of you may have like a grandparent or something that have done this for you, right? They put money into an account, like usually it's called a CD, a certificate of deposit, and then it will grow money for you until you're 18. You can't get it out until you're 18, but then it'll have more in it by the time you're 18. Okay, so this is how you figure it out. This is what we do. We start with the principal. So what's the principal amount here? $2,000. So $2,000 was deposited, and then we do parenthesis 1 plus. The 1 is because we're growing, right? And now what is our rate this time? As a decimal, get this right. As a decimal, Carla, what is it? Nope. David?
0.45.
Close. Cameron? 0.04. There you go. 0.045 is the interest rate. The reason is because 4.5%, right? We got to move that decimal back 2 spots is equal to 0.045 to go 2 spots. Divided by, and then it says N. N stands for the number of times we compound the interest per year. So in this problem, how many times are they paying out per year? You've answered. Somebody else answer. Go. Somebody else answered. Volunteer. Go, Matt. 4. Quarterly means 4 times per year. What is the N up here then? Is it the same?
4? Yeah.
It's also 4. Times my time in years. How many years is it going to be in there? 18. Okay, so let's do this in our calculator. Okay, so in our calculator, where did my calculator go? Oh, there it is. All right, let's type it in. So if we type this in, 2,000 times 1 plus, now we're going to have to do a double parenthesis here, right? Because I have a parenthesis around here, but I have a fraction in there, right? A division. So do parenthesis 0.045 divided by 4. Now I can end that parenthesis, but I have to end the other one. If you have 2 parentheses facing this way, right? Then you have to have 2 parentheses facing this way. And then we're going to raise that. What's 4 times 18? Does anyone know off the top of their head? 72 power. And then we're going to hit enter. How much money is in the account by the time this person graduates? And it's money, so we want to round it, right? $4,475.53. Is that worth it to put that money into that account?
Yes.
Yeah, what did they start with?
2,000.
Did they double their money?
Yes.
More than doubled, right? What did they do to work for it? Nothing. They literally put it into the account. That's how it works. Okay, that's it for video today. We are going to work on an exponential growth worksheet today.